வாரும் வதனமென திகழ்வரத கண்டமிழே. எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே. அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே. தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
சத்யவ்ரதம் சத்யபரம் த்ரிசத்யம் சத்யஸ்ய யோனிம் நிஹிதம் ச சத்யே. சத்யஸ்ய சத்யம் ருதசத்யநேத்ரம் சத்யாத்மகம் த்வாம் சரணம் பிரபன்னாஹ. वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः. स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम्. नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो.
Now I request our resource person, Dr. K.A. Venkatesh, Adjunct Professor, IITB, India, Professor of Mathematics and Computer Science, Myanmar Institute of Informational Technology, Myanmar, to continue the session. Over to you, sir.
Thank you, ma'am. I hope some of you or all of you might have opened Sage Math Cell and done some work. That would be easier. Today, as per the discussion as well as request from the participant, I'll go slow so that you also will have time to enter the code in MathCell and find the results. So having done limits, continuity and differentiation, so now it is easy to find out applications of differentiation, especially the maxima minima problem. So syntax is already known to us, only the procedure we modify it. So sometime one can write a function and you can call a function, that is also possible. But in the classroom environment, we want to go for step-by-step process. Therefore, I'll go with step-by-step process. Those who are interested, later part I can send. So I send the yesterday's notes, that is the Sage Math note in terms of Jupyter Notebook. I send across to the organizers, they will forward to you. So I'll start sharing my screen. So are you able to see my screen now? Is it visible?
Yes, sir.
Okay, right. I'll minimize the other part. Okay, right. So just applications of derivative. So this is the problem is given. Minimize C of x equal to minus 24x plus 36 times square root of x square plus 2250,000, so 2,25,000 and 12 plus 12,000. So this modeling problem you can take from any book, and just we are interested the process how to utilize here. Some problems are given. So now this is sometime what will happen is we may not use the usual process. There are some places we apply numerical approximation also. So therefore, I'll put both together in certain problems. Not necessarily I'll go with calculus alone. Numerical approximation also I'll do it so that you can understand how numerical process can be deployed over here. So this is a function, as we know how to represent a function. Then we are just drawing this one. The curve is looking at the turning point is going to be here somewhere between 0 and 1000. So this is the indication. With this, we want to identify a real root between 0 and 1000. Therefore, I can go for numerical methods. So that's the reason here I'm doing it. Between 0 and 1000, there is a root. So this is between 0 and there's 1000. So we have to find the first derivative and equate to 0. That is finding a root of that. So there is a syntax or a function available in Sage Math called as find underscore root.
It's actually அது நல்லா இருந்தது சார். எல்லாம் பைத்தான்ல கால்குலஸ் பேஸ்ட். நம்ம அத ஒழுங்கா கான்சென்ட்ரேட் பண்ண முடியல.
You will be receiving the material, ma'am, so you can utilize it. It is not Python based. It is built on Python. It's a different syntax. There are certain things. Python, if you want to use for calculus, you have to use SymPy. So that is different. And here directly you can interact it. Okay, anyway, it is good. Somebody is talking about yesterday's thing. So probably might have noted done this part. Please note down this part or use Sage Math Cell. Once it is over, I'll give for every syntax 2 minutes of time so that you can practice that also. So here only variable x is known to us default. We are defining c, therefore I define variable x comma c. So this is a function and this is a graph what is needed, y minimum, y maximum is given. Figure size you can play with that. This color you can change it, color equal to something. You'll do that. So after that you have to use this one. You have to tell the value of k. This is the Sage Math Cell server. You might have seen it yesterday. So sagecell.sagemath.org. If you go and type this, you will get this result. Whatever I'm talking about, you will get this one. So So it gives approximately the value is 11341.640. So how many digits you want, you can restrict it. So now what we are going to compute is numerically, we are going to compute it n of c of k. The value of this we are substituting in the function. So we got this the value. So instead of this method, what is the normal procedure? The same thing we did. Here what we done is we found the slope, first derivative, then equate to 0 in order to get this value. Instead of that, now numerical method, if I give the interval, we have to identify as a real root or real 0 of the given polynomial. So that is any method. So this is deployed find root used Newton-Raphson method. We know that Newton-Raphson method fails in certain cases. So that places we cannot solve this way. Why should I go this is so that you will understand numerical methods also can be addressed with this Sage Math. So that's an idea. Also, this n numerical will be computed. This is n of c of k is numerically we are computing it. Therefore, I put n of c of k. Yesterday also we used it n of expression comma digits equal to how many digits after decimal you required, you can put it. So hope you have done this part. Now this problem is concerned. I don't want to verify the second derivative and verify whether at this value whether second derivative is positive or negative. No need of verifying it because the problem is very clear, minimized. So now this curve is also look at that upward u. So obviously the turning point is lies between 0 and 1000. So obviously it attains minimum at this point. So this way you can talk about that, or if it is a step-by-step process, then you have to do the other way. So that is also we can look at that. So that's what I written here. The minimum occurs at x equal to this value and minimum cost is this. So as a note, I given minimum find root as well as n of ck is used to approximate the solution numerically. So now look at this problem. Read one time so that it is easy. The cost of packaging in the business related to surface area of the package. So especially when you buy a washing machine or a refrigerator, so obviously they'll give a big carton box around it so that it is safe when the transportation is concerned. So here what is our idea is, so the refrigerator is given, we have to create a rectangular box. So with a square base, all those things are given in such a way that the volume of the box is supposed to be 2 cubic meter. So what is the dimension required? So minimize this one. So one can find out, this is the normally what we do is generally we'll find the surface area, then what is a given condition, we do that. From that express multivariable as a single variable term. So then it is easy to do with the calculus. So that's what the given condition is, what's given as volume of the box is required to 2 cubic meter. So that can be expressed x square y equal to 2 because it's a square base x into y. So therefore x square y equal to 2. Surface area is 4 rectangular areas and 2 square. So obviously we'll get 4xy is this. So now we have to express y in terms of x. So this equation conditions can be used. Once you've done this part, then go to this part is much easier. I can express in terms of other way also. I can solve for y. I can take this one, y, what we have x square into y equal to 2, solve for y. When I say solve for y, obviously it's going to give us the same answer. So that is also I done it. So mathematically or hand also we can compute it. Now do this part is you can see that now look at this. This is the given condition equal to x square y double equal to. When this takes this value, you have to put double equal to, that is the not assignment operator we are comparing. So these are x square y equal to 2. Now I written directly y is known to us. The same solution, are we getting it or not, to verify? I use the syntax solve x square y equal to 2 comma y. This y is solving for which variable? So that's a thing. So if you are put x, you will get the value of x for y. So this value is, see this both are one and the same, 2 by x square. So which is, I'm calling it as R1. So here, this is the R1 we have, y is known to us. Now what we are to do is, this is the equation we have. So for what you have to do, first derivative you have to compute it, then equate to 0. So directly we can do it once s of x is, see this is put replace y by 2 by x square, then simplify, you'll get s of x as 8 by x plus 2x square. So now this part inside differentiation of s of x with respect to x. This gives the first derivative of this and equal to 0, solve it for x. So to find the turning point or stationary point, we use this. The moment you do this one, you'll get this part. I'll stop here so you can type it and verify, are you getting the same value? I can take this to Sage Math Cell and put there. On pressing this evaluate button, you will get the values. We are interested only real value. So obviously out of the solution, which is real value, you have to choose, and we have to do the second derivative. Then what is the value of second derivative at this point x, at the turning point? If it is positive or negative, then we have to go for it. If it is 0, then we have to use this derivative test fails, and then we have to go for second derivative test. So all those things calculus we have to play. So now we are not interested of calculus. So how to use Sage Math for calculus? Therefore, we are looking at this way, right? So have we done this one? So look at this. This is a I. I stands for the complex system. So here also I. So only one value. So out of 3, only one value is x 2 power 1 by 3. Cube root of 2 is the real root. So with this, we have to find out the second derivative and evaluate second derivative at this point. So how to do the second derivative? The same way, dif of s of x comma 2. If you put x comma 2, then you'll get the second derivative. Then you have to find the value of this. So directly I can do dot substitute x equal to this value. So whichever way you want. Yesterday we have seen that how to do that part. The same thing I'm going to do here. See, this is just to confirm whether the roots are 2 power 1 by 3. So that is a graph I drawn it. That is not required. As I said, now second derivative we are computing it. Differentiation s of x with respect to x, the second derivative 2 dot substitute x equal to 2 power 1 by 2, it gives 12. So now this second derivative is 12 positive. Therefore, the function s of x attains its minimum at x equal to 2 power 1 by 3. So that value is given. But the question is, they ask the dimension. So in order to find the dimension, we have to use the given condition. What is the condition is given? The volume supposed to be 2 cubic units. So use that equation. Having value of x, find the value of y. Already we expressed y as 2 by x square. If you substitute it, we'll get this value. So hope you have done it, this part. If you have done it, so now you know how to do maxima, minima. There is one more problem here. This kind of problem only always needed a lot of application. You can see that there's one such example. I've taken it from the modeling book, Calculus Modeling and Application, second edition. So you can look at this book, or there are certain problems from Thomas Calculus 12th edition. Also similar problems are available. There's a football stadium. The normal gathering is this much. The ticket price is $25 for a football match. If the number of audience increased, provided the capacity is given. So all those kind of problems, similar problems. So one such problem is this. Or if you look at the SAM series calculus book, it talks about per acre 25 mango trees supposed to be put so that the yield would be maximum. Beyond 25 trees, if you add it, the yield is reduced by some unit. What is the optimal number of mango trees so that maximize the revenue. So that is what similar kind of problem. Here also the same way. Here the first is framing the equation is slightly tough. Once you understood one particular model, then the similar way we can do that. So here what they are saying is the ticket charges is 500 if they exactly 80 people sign up. Even a person increased by 1, number of passengers increased by 1, so $2 is reduced. So then we don't know how many people are going to sign up. So 80 is the minimum. So 80 plus X is the number of passenger. The cost per passenger is going to become as 500 minus 2 times X. So this is what we have. So this is the revenue part. So revenue part is known. Then you can see to confirm whether this one is, we can use the differentiation but when you draw the graph, you can see that where the turning point looks like one can apply numerical methods, or directly one can do usual way also. Now look at this. This is the graph corresponding to this. See, this is the place maximum. So it is lies between 50 and 100. We can do find root, but the calculus is concerned. We do first derivative equate to 0 in order to find the value of X. So solve differentiation of this function, revenue function, X equal to 0 for X. So X equal to 85. So in order, in the sense, the total number of passengers is 65. The revenue is going to be maximum what is the cost per passenger? That can be computed by, we know what is X value, substitute in this one, 500 minus 160, 85, 2 into 85, yeah, that is, you substitute it once. Yeah. Substitute it, you will get the value, right? So X equal to 85. So we are not doing it, the second part at all, because this is very clear from the picture, there is no need of computing it second derivative. So it is up to us to go all the way by the process or understand the problem and solve it. Is it clear? Can I move up? Or you need time? Okay, I'll go to the next problem. That is what I said. So we're computing it before. So Newton-Raphson method is also known to us. How to do this Newton-Raphson method? That's what we are talking about. Find a real zero of f of x equal to ln of 6 minus x square minus x. So here, what we are to do is we have to give the initial value. The formula is known to you. The k plus 1 iteration equal to the kth iteration minus f of xk divided by f dash of fk xk. So that is what I written as xn plus 1 equal to xn minus f of xn divided by derivative of f at xn. So this is been known to us. It's an iterative process, therefore we need using the table part also. So looking at the graph, so this is crosses the x-axis somewhere in between 1 and 1.5. So either I can start from 1 x0 or I can start from 105. Once you identified the route where it lies, we are going to identify one real route. So we are going to do that part. So that is, I'm defining that Newton-Raphson method as the function called as nu n, Newton. So x, the formula is x minus f of x by differentiation of f of x. So the initial value is 1.5. I'm taking from this direction. So I have to come 1.5 left side, I have to come. So I have to define 1.5. I'm defining as a float, 15 by 10, that is x initial. So 8 iterations, I want to go for it in the range 8. X initial equal to new x initial. So print x initial. So this is the values we are going to use it. 1.1.9. So when you substitute it in this formula, automatically it is going to give us 1.39. So Newton-Raphson method also can be solved with the help of this. So I'll break here for 2 minutes so that you can verify this is working or not. So for that, you define this part also. Variable x comma f of x equal to log 6 minus x square minus x. This is a function given. So this is not required to understand. To find the initial value of x0, I taken as the graph. Or what you can do is, there are many methods to find the guess. One is you take, what we do is we take arbitrarily two values, we substitute that values in the given function. F of a into f of b is less than 0, then there is a root lies between a and b. So use that. Or if you want to go for more precisely, Sturm-Liouville theorem helps us. So that is also Sturm sequence. You can form it and you can find out that also. So there are so many ways. So easy way is because we have a tool, pictorially visualization is much easier. Therefore, I went this way. So done this part, and this also you might have done it. So this, please. Once some of you are working on, please put on the chart window, it is done, so that I can understand, I can move to the next problem. So this is everything today. I'm going to talk about minimal so that I would cover maximum possible thing. So this is Newton-Raphson method. I'll go to the next one. So the next part is, so more or less we have talked about differentiation nicely. So now there are certain problems like mean value theorem. All those things I did not talk. I'll be addressing mean value theorem for integral calculus. Therefore, you can use the same way. So mean value theorem is also used the same way. You can define as limit is known to us. We can talk about that. Now, integral, what we done, the syntax for differentiation is DIFF of f of x comma x. If you want the second order derivative, x after x, you have to put the number n. N stands for nth derivative. So the same way here, integral, we have one is indefinite integral and definite integral. So we are known one is within the between the limits. So that how to do that part is we are going to talk about. The syntax is very simple. Integral f of x comma y comma x, indefinite integral. The same way integral f of x comma y x comma a comma b. The limits, upper limit and lower limit is given. Normally when we talk about integration, in general integration in the sense it's a Riemann sense only. So the Riemann sense in the sense the domain of f is partitioned into various subintervals. Then we define in that subinterval where f of xi takes maximum. So then we define upper sum or lower sum. You call in the analysis UPF, UPF U of p comma f upper dot box sum equal to sigma equal to 1 capital Mi delta xi. The same notion. So that is we are going to split the area between the curve and the coordinate axis as rectangles or so rectangles or some trapezoidal way we can talk about. So whatever it is that can be achieved here also. Now the question is, can we do directly this way or using Riemann sum also? Both are possible. So now when you say this way, then Riemann-Stieltjes, you can talk about that. Riemann-Stieltjes also can be done there. For that we need another function alpha, so that we are not going to discuss over here. So now you have integral of x cube minus 3x plus 2. So just integral of x cube minus 3 times x plus 2 comma x. This x stands for integrating with respect to x. So sometimes what will happen without this also works. Always better practice is please use integrating with respect to x. So now once this is done, you can take many problems and say the syntax is very simple. Integral of within braces f of x comma x. So it will give this one. So now when you talk about that, now look at this one, integral of x cube plus 2 power 2. That is x times x cube plus 2 whole square. So integral of the same thing. We are not worried about this. Suppose you want to simplify, then integrate it. You can write f of x dot simplify I underscore full open bracket and close it. You can do that also. Now this answer is 1 by 8 x power 8 plus x power by x power 5 times 4 by 5 plus 2x square. So this integration is very easy. How you can multiply this one? So first is abbreviate, expand it, then multiply by x and integrate it. Power rule will get this way. Now what find integral 2x by square root of x plus 1. So the final answer I want to simplify it way instead of term by term. Here everything is in terms because all terms are different. It is fine here, not necessarily different. Therefore, I want to simplify. So that time what we are going to do is integral with the function come with respect to the what variable we are going to integrate it, x dot simplify full. So the moment you do it, if you are suppose if you remove this part, I'll just take this one to Sage Math cell. I remove simplify dot. See 4 by 3 x plus 1 3 by 2 minus 4 square root of x plus 1. Simplify full always gives the simplification, simplified form. Now they look at this 4 by 3 square root of x plus 1 times x minus 2. And here the answer is 4. See, this is 4 square root of this. So this common terms pulled out easily. So directly one can do for further processing. Depending on the need, you have to utilize which syntax is required. Now one more problem is involving trigonometry functions. So 2x square times sine x cube. So integral that is minus 2 by 3 cos cube. So now you may ask, suppose if it is involved substitution or trigonometry substitution or inverse trigonometry substitution or partial fraction, will it work? This does a job obviously without any worry about whether I have to do partial derivative or integration by parts. Everything it takes care. So that is this is what now what we are going to do is integration as the limiting sum. So that is also possible. One can talk about that. So now when you talk about a Riemann sum, one is we take, there are three methods we talk about. One is left point, right end point, then midpoint. So that is we have to define precisely. So when a number of n is given, number of subinterval is given, and f is defined on a comma b, Now the number of subinterval is we can define as b minus a by n. So that is what we are going to do. So here this f of x is given as x square plus 1 on 0, 2. The partition is also given p equal to 0, 1 by n, 2 by n. So what is the meaning of that? The equal with 1d. So the width of each subinterval is 1 by n. So using that, we have to do approximate the integral f of x between 0 to by Riemann sum at left end point. So then after obtaining Riemann sum, what is the integral? Integral a to b, sigma limit n tends to infinity, sigma n equal to 1 to infinity, f of xi star delta xi. So f of xi star is known to us. So the maximum point or minimum point, so whichever you want, you can take it and we can equate it. So that's what we do. As n tends to infinity, that is converges to integral value. So why should I do? Just the classroom environment, we talk about Riemann sum, then we go to integration. So for that, whatever the things you want, a is b are known to us, n is the number of subintervals, f is the given function, x is known, I is the width we are going to multiply with this number, which is subinterval, left rs, that is left endpoint Riemann sum, x star, that is the maximum or minimum value attains that, b is the width of the interval, b is the width of the interval. So defined inside a variable, this all variable. So as I said, with this nothing but b minus a by number of subintervals. So f of x is given, x star is a plus I minus 1 left point. Suppose if you want to go to right end point, this you change it as a plus I times d. Only changes right end point, I plus d. So now the Riemann sum is required. What is Riemann sum is? The f x star I d comma I 1 comma n, and this is the subinterval we are going to talk about that. So once you say this is going to become a forms of table, this place, what is the extra part I used is I want header row supposed to be n and row sum I want. So frame f frame is true. So like a table will come. So what is the value it's going to get? So that is the only difference I used it. So now directly one can do integral value or left end point or right end point. Suppose midpoint you want to do, what will you do is I by 2 you put it instead of a plus I by 2. So only important part is how you are defining x star. That takes you to left end point or right end point or midpoint. From there, the remaining values are here. So when I want to go for right Riemann sum, what I do is I change left as right. And if I want midpoint, I'll take it as mid one. So when you draw these squares, the area between the curve and the x-axis, you draw the rectangles, left point, left end point, or right end point, or midpoint. So that is depending on the problem, or the same, all will converge to the same value. So to do that, we have done this part. So now what is the value you're getting is 100 intervals I've taken, 4.627 is the answer. So 100 rectangles, we are getting this one. So now, as I said, left end point, what is the only changes as n tends to infinity, this is going to become as 14 by 3. So now we have to change it as right end point, a plus I star, I times d, that width of the interval. So change the left. Now what you can do is, I'll put this one, okay, in the one, I'll go here. This is for left end point, left Riemann sum. So now here you have to do it as right. So change it as, instead of -1, you remove -1, do this one. This you change it as a right RS. What is the value you are getting it? So I'll give here 3 minutes time so that you can type and experience it. The change I'm doing here, I star D, so this is not required. Left RSS, I'm going to change it as right RSS. I defined everything. Okay, variable is defined. So exactly by Here, this 10 is the starting point. Maximum value is 110 in step size 10. I'll now evaluate it. Okay, because here I did not change it. So this is, I have to change it as right RHS. Now I'll evaluate it. See now, Sage Math Cell, how nicely it gives the table because the frame is true I put. So now we are getting this way. Now what you have to do, as limit n tends to infinity, what is this value? Now look at this one after table, what I done. So here we are talking about 100 angles. Limit left RSS 0, 2, n equal to infinity. So I'll check this also so that you will see what is the value for that. Now I remove this part. Because here what is the problem is when this is value, the previous value is not there, so obviously it won't compute it. So again I have to do this total part. Okay. Okay. Now I want to store RNSS. Okay, I need this value as I'll go for me. Suppose you want this table as well as this, what you can do is store the table in a variable. Okay, this value as L equal to, then I'm going to do not this, yes. Then square bracket, I cannot write that way, K comma K plus L. Okay, I should remove this part. Only it will show okay, because again this change I did not do it right RHS. Okay, now I can say K L. It's working, so therefore I know it as. So the final answer is 14/3. Whether if you do now I'll go back to this one. Whether you do by right endpoint or left endpoint, that is known to us, so it gives the same answer. So this is the way you can do it. As I said, this is the right endpoint. The same way mid endpoint, what you do is I minus 1/2. D if you do it, midpoint will get it, then mid RS. So this is for the definite integral. We have a nice theorem, fundamental theorem of integral that says that f of x be a continuous function on a comma b. Integral a to b f of x equal to f of b minus f of a, where capital F dash of f equal to small f, antiderivative of f. So it says actually two part. This is one, and whenever f of x equal to integral f of t between a and b, then capital F is the antiderivative of f. So both way you can talk about. So now, what is the difference between this and definite integral, indefinite integral is the endpoint, the limits we won't define it. Integral of f of x, comma x, a comma b. So between 1 and 5, the only difference is 1 and by. This gives this way. Now the same way, now if you talk about find the integral of square root of 3x square minus 2 by 2x between square root of 3 comma 2. So the limit also having square root, that is the usual way only we are going to write. Just I want to ensure that that is also covered. Ensure square root of 3 comma 2 ab, when you do it, you'll get this one. Now this is, suppose yesterday's discussion I did not talk about the inverse trigonometry functions, so therefore I want to give differentiation of arc sin x. That is just for saying that it is also possible. Now when you do integral of cot x square x comma 0 comma 1, so the analytical way, when you do want to do this one, it is won't possible. So the numerical way is only way we have to evaluate this kind of things. This as well as tan x square, the good examples of we cannot do the general way. Numerical integration is possible. Therefore, I'm using it n of integral cot x square comma x between 0 and 1. It gives the value like this. So now the substitution we use it. So what is that? For example, if you take integral of x cube by x plus x power 4 plus 2 whole square. So here what we do is, by substitution method, we have to take u equal to x power 4 plus 2. Then du we have to calculate. Algebraic manipulation we have to do, because du is going to become as 4x cube by 4x cube by 4. Here x cube is there. Multiply and divide by 4. So we have to do that algebraic manipulation. So there is no need of worrying about whether substitution which taking it here. Just type integral of x cube x power 4 plus 2 whole square comma x. So the answer is one and the same. If you do it by substitution method or partial fraction, when we go for partial fraction, all the 4 various ways of partial fraction we have to do. Always long division is also required. So polynomial division, the moment you put on this one problem, you can solve, 2 problem you can solve. The student's supposed to practice it. After practicing it, in order to verify the results, this can be given as given to them. So you can say you can use Sage Math to verify the answer. So that is the easiest way. Integrate 2x power. So this is for long division as well as partial fraction is required. So what we are going to do is, this is the problem: 2x power 5 plus x square plus x plus 1 divided by x square minus 1. So if when you do that, so it is going to become as some quotient plus. We are using that division algorithm. So obviously we'll get quotient plus remainder by the divisor. So that form you write, then partial fraction you define it. So it's a lengthier process. Now if you look at this integral, same thing, no change at all. The answer is, it's going to become as 1 by 2 x power 4 plus x square plus x 1 by 2 log of x plus 1 plus 5 by 2 times log of x minus 1. So any problem, only syntax is you're supposed to remember is integral of f of x comma x comma limits if it is definite integral. Otherwise, directly one can talk about that. So then the integral of integration by parts also the same way. The previous problem, you look at this, if you solve by hand, what is that? X power 4 plus 2x cube plus 3x plus 1 divided by x square plus 1 whole square. We need long division, partial fraction, then inverse trigonometry substitution. You have to draw the triangle, find the theta, then substitute here. All those things are done easily. So, but the student, in order to make the student understand, couple of problems solved by both, then we can use the tool, say that you can verify. Answer is given. The student can do by hand and verify it easily. So this is the arc tan x tan inverse is involved. So inverse trigonometry function comes into picture. So logarithm is anyway, we have seen that. Integration by parts also the same way. Integral of there are certain problems we have to do integration by parts. When start solving with integration by parts 3 times or 4 times we do it. So all those things is addressed in one line. So then integral of this is another part. So inverse trigonometry function will come into picture. So this is, so applications of integration. Okay, this is, I talk about this problem. There is an error, right? Applications of, so now area, majorly we'll talk about area between the curves, the area of the curve between the coordinate axis. Then we talk about surface area of revolution, volume of revolution, all those things we'll talk about that. So I'll talk about that part only. Now you can take this problem. What is the thing is, identify the area enclosed by 2x times x square minus 4x plus 2 and x square. So two curves are given, area between this. So in order to find this, The best way is normally also we insist the students also to draw the graph, then we can solve it easy. Why do you want to do that? Because when you want to talk about the area, which is the topmost one, lower one, point of intersection, we have to calculate all those things. When you draw here, there is small area lies here also, and this area also. So we need this too. So we have to calculate this one. So to find point of intersection, what is the procedure we have is solve these two equations, equate these two and solve for x. We'll get the point of intersection, this point and this point. One point is known to us 0, 0, and this point is known. Then we can find out the. So take this one, type it. So I'll slow down here. So f of x equal to 2 times x square minus 4x square plus 2 up to draw the graph and plot identify the point of intersection. Up to here you can do it. I'll do this one. Okay. Hope you have done it. So now point of intersection is x equal to 4, x equal to 1 by 2, and x equal to 0. I said 1, this is 1 by 2, and this is x equal to 4, if you can see directly. Now what we have to do is we have to see that which is the topmost one. So accordingly, we have to play around this one. So f of x is, look at this, f of x is 2x x square. So obviously parabolic 1, the green one. Suppose you want to do separately, what instead of that, what you can do is draw the graph separately in the same coordinate axis. Then different colors, you can know which is the color. So here default is, if I'm not saying the color, default is blue. When you go for second one, obviously it's green. You can change the colors as we talked about this. So now first one is here. One is 0 to 1 by 2. Another one is this is we have to see that accordingly you can write f of x minus g of x or g of minus x. So the limits as per this, one is 0 to 1 by 2. Another one is 1 by 2 to 4. Whichever is this. So integral of f of x minus g of x, x0 1 by 2, integral g of x minus f of x with respect to x, limits are 1 by 2 comma 1. So we got 517 by 16 units. So square units. So this is the way you can talk about that. The next problem is find the area enclosed between absolute mod 2x, absolute value of 2x, and cos x. Cos x interval is given minus pi by 2 comma pi by 2. So this is what is there. When you draw the graph, you look, the curve is better. So when you go to the classroom like this approach, obviously students also feel like graph looks good. So, and they also know where the curve process or which is above the other curve easily visualized. So then they can solve easily. So a couple of problems are in what I used to practice is if weekly 3 or 4 sessions I have, whatever I do, the 3 sessions, the last session based on this tool. So that is the easiest way, so that all problems, one or two problems, every model you can solve using Sage Math. And you can give, whenever you give an assignment or a homework, certain components you give them on as this one. At least let them write the code and send across to you. You can verify the code. Or after verification, the best part is give the feedback in terms of if it is a wrong, give the problem in the put a common place or give to the students by today. Most of the things are happening online. So you can solve the problem and send them by WhatsApp or whatever the group you have. So that is one. So when you do this one here, now again, we know what we are going to do it. We want to find of intersection of between this one. So I can find a real root and I can go for it. Numerical integration, I can go for it. So therefore I defined it this way. So this is area between the curve. What you can do is take at least 10 problems or variety of problems you can take and put on this Sage Math, and you can do it. There are places Sage Math also don't depend on Sage Math. One such problem today morning I encountered is it gives a different answer, which is supposed to be something else. So that could be very minimal. If you come across, you can report to the forum. The forum is very active in the sense that if you send any doubt to the Sage forum, you'll get the response within 2 hours time. That is a maximum amount. Anything you put it, immediately you'll get a response. So very active group. So that way you can get the help from Sage. Those people are regularly using it. You can get the help from them also. So this is one. Again, I said, depending on the things, you can use this one. So now the average value and mean value theorem of integral calculus is almost same. What is the difference between average values? Average value, what we say is average value of integral average value of the function f on a comma b is 1 by b minus a integral a to b f of x dx. In the mean value theorem, what we say, this average value is supposed to coincide to a point c, f of c equal to this average value between a and b. So in other words, there is a point between a and b c such that f of c equal to 1 by b minus a integral a to b f of x dx. So that is what we have. So both can be clubbed together. Once you find average value, the choices to find out. So what do you mean by that? You have to identify a point in between a and b whose value is equal to this one. So solve problem only. So what is the meaning of that? Once you identify this f average, solve f average equal to c. So if you put it, then you'll get the value between this. So that is the only small change you are going to do that. Now that's the thing. I've taken this problem. F of x equal to 3 sin x minus x. Find only positive root 1. So find one of the positive roots are of f, not only all positive roots. Okay, one positive roots. Calculate the average value of f between 0 and this positive root. Then this is nothing but find a value of c which satisfies mean value theorem for integral on 0, r. So now, in order to do that, always the integration is concerned, we insist to draw the graph. So draw the graph 3 sin x. The graph looks like this. So to find a root, so obviously one real root is required. We can use the function find underscore root. So f of x equal to 2, 3, this gives. So just you compute this part. So from here, I'll take this one, f of x equal to 3 sin minus x. So this I'll take and I can put it as 2, 3. Why I done this is 2, 3 is, so between 2 and 3, there is a positive number. So this side, if you see that 0 and minus 3, if you take, there is a negative real root. So we want one real root. So 0 and positive real root. So obviously we take 2 and 3. So this applies Newton-Raphson method and gives the answer. So 2.27876, find the root. So now what you have to do is average value, you have to compute it. So in order to compute this, you have to express in terms of a float. Therefore, I written this one. This all algebraic manipulation only. Then the formula, what is the average value formula? If you go up, you can see that 1 by b minus a times integral of f of x between a comma b. So now 1 minus b minus a, we know 1 is 0, r is found. So different 1 by that part times integral of f of x is 3 times sin x minus x between a and b. So 0 and r. So that value, if you put as one line, average values got it. So f average equal to 1 by r minus, already defined what is r, integral of f of x with respect to x, 0, r, 1.031. All such problems can be solved, right? Now, what is the left out is, we have to find out c such that f of c equal to f of average. So that is, again, find a root f of c minus f of average 0, 1. This gives the answer 0.55. So this is, now you have, okay, next problem, you'll be doing it. I'll just, this is volume of solid revolution. So we are going to talk about that. So here, again, Riemann sum only will be using it. So pi times integral of f of x square between a and b. So if it is depending on the axis of revolution, whether it is y or x, that is basic. So I'll be talking with respect to both. So now the problem is, Find the volume of solid of revolution obtained by rotating the region bounded by the graph f of x equal to square root of x plus 1, comma x-axis, and the vertical line x equal to 2. So we want this. So the best way is drawing the graph of this. So take this one, draw the graph. I'll wait for it.
என்ன தண்ணியில ஓடுது, அதனால சாக்கடையில ஓடுது. சாக்கடையில
See, now you have this is this when you are using Sage Math Cell, when you want to do it, every time this f of k or f of x, whatever you are defining it, that should be retained, because we won't stop here. Just this Sage Math Notes Math Cell. So obviously slightly different. Sage Math Note is different from Sage Math Cell. So this has all those things I can put consecutive way. So step by step, I'm going here. Once you do this one, now you can imagine it, how it rotates faster rate. Probably during our childhood days, we might have played. Nowadays, what name it is called, I don't know. Putting the washer in it and put a thread and pull it like this, both direction. It forms nice revolution. Or if you have a bottle, put a bottle along a thread and rotate it faster rate. That way you can demonstrate certain things also. It is up to us to demonstrate and all those things. Now, this just shows 2D. When you do revolution, it's going to form a 3D, how it looks like. So this is the place Sage Math has a better advantage. So now I have to say revolution, how it is revolving it, revolution plot, I have to talk about that, and 3-dimension. So that is the syntax is a revolution plot 3D. So now here I'm calling f of k. But when you Sage Math Cell, f of k is gone. So what you have to do is, instead of f of k, here you have to write square root of k plus 1. So put square root of k plus 1. This the value k takes between 0 and 1. Now we are asking, show the curve equal to true. Whether the transparency level, how much you want, that is, you can define this with or without that. If you are not defining it, it will become the solid this way, gray. So to give this better visualization, so we are defining this one. So about which axis we are going to talk about that, parallel axis x. Then the aspect ratio, whether you put it or not, aspect ratio, I should not talk about that because all of us are familiar with aspect ratio in terms of camera and other things. So now this is optional. So you can do it and verify, are you getting? Only change you have to do is here. I'll take this one. I'll go to Sage Math Cell, so that this is not required for us now. This is supposed to be SQRT of k square plus 1. Am I right? K square plus 1. That is the equation. Let me see. Yes, k plus 1, not k square plus 1, k plus 1. So the moment I define k plus 1, it will say error because a variable is not defined. So I defined variable within single quote k. So this is the syntax. Now square root of x k plus 1 k square. This is defined it. I'll put evaluate. Are you able to see? You can enlarge or this is the thing. Now you go there, I'll go up. So please type it and verify it. So now you can play with this. So when you use this one, you can string it. See, now you can reduce the size so you can see all the points. So which axis where it goes, and you can change the colors also. So that is, once you start using it, you will play around it. That is, so now the syntax, new syntax is revolution underscore plot. Yesterday also we have seen one more called as implicit underscore plot. For when the equation is implicit form is given x square by a square plus y square by b square equal to 1. When you want to play both variables, define variables and implicit plot we defined. So now we can define a revolution underscore plot 3D. So this 3D plot is taking care of this, how it looks like. So now there are three methods to find the volume of cylinder. One is the what we call shell method, then washer method, disk method. So all the three methods one can talk about that. So now it is easy to visualize any problem. Then we can find out which is better, how we can go about it. So that is an idea. So this is what I said. So now you have this. So now what is the formula? If you use the pi into integral f of k square, f of this values, what is given as the formula is pi integral a to b f of x whole square. So that is the first formula when you are using it. So pi, that is, we don't know the value of integral, so we are multiplying it. So between the limits 0 and 3, so we'll get 15 by 2 pi. So this is one. Now the volume is given. So now this is washer method. What we do is in between there is a hole. It will form two surfaces. So we have to calculate it in the same way. We will multiply it. So pi into integral gx square minus f of x square, provided g of x is above the g of x. So that is a condition we use it. Otherwise we put, that is a small changes. The formula only changes. So then you have to identify between what values g is more than f, or sometime when you draw the graph, you can understand it will be have to integrate 3 or 4 different parts in order to get integrate. In the sense we have to separately find the volume, then we have to add up. So that is also possible. So this is the place a pictorial representation is much better. Find the volume of the solid generated by revolving about x-axis region enclosed by y equal to 2x square plus 1 and y equal to x plus 2. So up to here, you can do it. Remaining part, I'll give you some 7 minutes time after doing this plot. You can use formula is given. What is the formula is? Wherever g is greater than f or above f, you can use integral of this. Do this one and tell me the answer. So this part you can take. Variable k, f of k equal to 2k square plus 1. G of k is k plus 2. Both graphs we are placing it in the same coordinate axis. So whatever given is done. So we have this is.
Weird sound கேக்குது.
Angles are
Hello, Thirmal? Yeah. Hello, am I audible?
Yes, sir.
Now in between it got disconnected, unfortunately.
Okay, sir.
Yeah. You please allow me to share the screen. Yeah.
So your name is added as co-host, sir. You can do it.
Okay. Are you able to see now? Ma'am, are you able to see my screen?
Yes, sir.
Okay, right. In between, it just got disconnected, unfortunately. So we are talking about this problem. So now, the same thing I take it into this Sage one part. The other part I have to take into that way. So now, if you do that way, there are two parts is required. So I'm putting it this also, the same place. When you do this kind of things, you have to put same way. Now both are available. Then I have to put, there are two ways you can define show G plus F, I can put that way. F plus G integer parallax to name show. Okay, I put cap. This is small s only, right? Yes. So now both are in the same picture. So now from here we have to, this is a usual practice. What we do is then we have to integrate that. Once you got it between this interval integrated, so that is going to become as 81 by 20 pi. Now the first, what is the change in cylindrical cell method is we change this one to 2 star pi integral f of x between a and b. So this problem you are doing it. I'm not going to do anything else. Another 15 minutes I'll give you, so I'll increase the size so that you can do it. The region is bounded by the curve x square plus 1, the x-axis, and the line x equal to 3. Find the volume of the solid by revolving this region about the y-axis using method of cylindrical cells. So only difference is the formula will changes. If it is x, we have to put it here. We have to solve for y. Then we have to put between a and b. Normally we put in the theoretical way c and d, the values whatever it is given. Okay, might have done. I'll take this all together to the Sage Math cell. That is better. This plot, I put some variable t equal to so that anybody is typing from here, you can type it, then you can understand together. So the entire, okay, before that, I have to define this as variable k. So when you've taken this problem, you have this, when you put one line, what will happen is only the final answer will be visible. So therefore, what you can do is you can put a comment line from here, whichever you want to show, that is a part, show it. Remaining part, after put a comment line. Now, for example, if I put from here, hash one by one, I'll go. Type this also, put. Okay, this is already comment line only. First is just, we are seeing that how this graph is now. Okay, this P, okay, I want to see P also, therefore I have to put P. Otherwise, now we have P. Okay, but I'll put this also. T. This is not required, right? Now only this first 4 lines will get evaluated. Variable k comma, oh, already there, so no need of this. I thought it is not there. Okay, right. X square. Okay. Okay, it is getting evaluated. It is not displaying because I've stored in a variable. Therefore, it is not visible. Now it will be visible. So this is the graph we have seen there also. After doing this one, what we are doing is how it is when you are revolving it, how it looks like. So for that, we are going here. So now I remove this T. T is not required. Displays only this part is now needed. Okay, again, I have to put P. Right. Now here, what you can do is you can minimize it, whatever way you want to rotate it, so that everything can be visualized. 360-degree can be discussed. So this is an advantage of doing this visualization. That's the reason I said when you go for Sage Math, so now all the points where it is going on, everything is very crystal clear than when we do on the board. So the 3-dimensional visualization is much useful. So now what you have to do is when you are involved in total course or a particular problem, take it 3 problems like this and other problems in the board. When we solve it, student can understand. You can ask them to verify the same way. Assignments can be given or ask them to give a presentations to other students also. That is possible. Now total area, when we want to go for it, we have to split into 2 parts. That is P plus Q we needed. That is a total area we are looking at. Now what is this? Look at this. Earlier I used show P plus Q. Instead of that, I added both in one variable, s equal to P plus Q, s dot show. This function also works. So now we put this one, evaluate. So now the picture is, when it is both, it looks like this. So you can see the solid difference between this and the previous one. That's a way of visualization. Now, just this is a formula only. To find volume, what we are going to do is 2 times pi times integral of x into f of x, then between the given limits. So this gives the only one answer. Now it will throw. So this is the final answer we'll get is that's okay. This is supposed to be not required. All the graph and 99 by 2 into pi. So this is the way you can talk about that. And in general, we talk about 2 important problems when you go for surface area of revolution. One is volume of the pyramid as well as the volume of the sphere also. So both can be discussed here also. That is a common problem. So therefore, I want to talk about that. This is now sketch the ellipse standard one, that is x square by a square plus y square by b square, and the volume of the solid obtained by revolving the region enclosed by the ellipse about the x-axis. So this is just you copy down, don't execute up to first box. You copy down in your Sage Math cell. then run one after one, what I'll say, then you can run it. So ellipses, when we are talking about ellipse, so here we are taken A as 1 and B as 2 for some reasons to get the answer. Otherwise, it will be in the general form. So for that only. So this is the implicit plot. Yesterday we talked about that. This is you take as it is. I'll put in the Sage Math cell, then you can borrow it. I'll put together, then you can work on that. So the first 4 lines, we are talking about just the given equation and the graph of that function. So x square by a square plus y square by b square equal to 1. And we taken the limits x equal to x is minus a2. This is supposed to be minus 1. Okay, minus 1, a plus 1. Okay, right. Now it is correct. X comma minus a comma a minus 1, that value of x, range of x, range of y. So this is the thickness of this line. After that, when we are saying this is going to, I'll run this one so that you also can verify it. So we got the ellipse. Now, the moment you got the ellipse, what you're going to do is revolve around about the x-axis. So what will happen, that is we have to understand. For that, we need this one. So I am removing this part. So to find, when you want to revolve and we have to find out the point of intersection. So we are solving, now it is an implicit function. First we have to express in terms of x only. So for that we are finding the value x square plus y square by b square equal to 1, solve for y. So that is nothing but implicit to explicit, we are changing it. Then finding the solution, and we want positive value. So that is a place we need. So up to solution, if I run, you'll see some value. Now here minus square root of a square minus a square by into b by a. This is negative value. So we want positive value. So we are taking this value as. So to pull out this, yesterday itself we talked about that. Therefore, I stored this solution. It's stored in a vector form. So there's a 0th position. There's a first position. So I want to pull out that value. So I'm putting as a function f of x equal to solution 1. That is a position. RHS, from RHS we are pulling out this one. So now if I put f of x alone, you'll get only one part, that f of x value. So f of x equal to, this is what we wanted. Now we have this. So we want the values in terms of a and b. So we have to put f of x, we have to substitute this value. That is going to become as now the f of x when a equal to 1 and b equal to 2, what happens? So that is, we are computing it. Okay, I did f of x and f of x equal to substitute. Okay, if sometime it gives trouble, then I'll use print f of x. Yes, so this is printing f of x. You want this value here, I can do after substitution. I can put here. Okay, this place I did not put f of x, therefore it did not give. So square root of a, that is the value. So when you substitute it, you got this value. So now finally what we are to do is we want to see how a revolution is taking place about the x-axis when we are rotating it, the ellipse. We want to see that part. Okay. Here also I did not show yes. No. So there's a value. Now you can see rotated. So any direction you can see the values. What is the value it takes? Y-axis here, x-axis here. Between what limits to? Everything can be discussed precisely. Now once you've done this one, finally we have to calculate what the volume of the area created by revolution of this ellipse with respect to this. If you put this one, it gives some answer. So 16 by 3 pi. So this is the answer. Now using this for a general ellipse, when you rotate it, what happens? That is what I put. Volume of the ellipsoid is for any a comma b is one line. It gives this one. I'll put it directly. I did not do all such things. Now here, f of x is, if I do this way, it won't work because f of x is solution 1. So I need the previous part also. Okay, I'll do Control X. This is not required. Okay, I'll remove from. This is. So 4 by 3 pi ab square. So we get anything. If you want, you can try out with this way. So whatever possible I did is what I have for you today. Now I can open for questions. We can discuss whatever we want. We can discuss now. What is the thing is, best thing is, if I'll show you some more places you can learn from there easily. The moment if I put, suppose I want a 3D plot, Sage Math. I'll put one more line so that you can learn tutorial. Yes. So now here, if you go any topic, you suppose if I go to basic algebra and calculus, whatever I discussed beyond that also available here. So basic algebra, solving equation exactly, solving equation numerically. Today we use that also. Differentiation and integration. Suppose if I go differentiation, you can see that what and all defined variable. So this is only this much they given. Now what is our job is, this is an application problem. They put it in a so differential equation, how to solve differential equation also. So this place you want something called as Okay. Okay. So this is, now you can see that this is actually taking from Sage. The Sage is taking from, there is, I said, there is a software called as WX Maxima. WX Maxima is a little easier than this because everything is in a pan arrangement, and the pan arrangement, it has been given in a different way. So it is easy to pull it out nicely. So you can think it of that way also. Sorry. Any help is available on SageMath tutorial itself. You can make use of the tutorial. As well as I send you some, whatever I discussed in the classroom, I send you yesterday's thing. Today's things also I'll send across to you. We can now discuss. I stop sharing the screen. Yes, I'm open for discussion. Any questions? At least yesterday some questions were there. Today no questions. So probably they have started using it, SageMath.
Participants, is there any question? I think no questions, sir.
Okay. Nice.
Thank you, sir.
Yeah,
Thank you, sir. We had a very, very nice session. That was very interesting also to see all the graphs, which will be really very useful for the students part when we teach them.
Yes, ma'am. Yeah.
Participants, any questions from your side? Any other? Please unmute and you can talk if you have any questions or anything to be asked.
That would be great.
Okay, as there is no question, I think we will end the session with vote of thanks, and also you can give the feedback form which is shared now. Any other questions from participants, or otherwise we will end this session, and I'd like to give vote of thanks. Any other questions? I'll give 2 minutes time. Those who are working online, if you have any questions, you can ask. Otherwise, we will go for the end of this session.
Sir Venkatesh, sir.
Yes.
Sir, is it possible to use this for our inventory model and all? For research purpose, I'm asking.
Okay. See, I have not explored inventory model using this one. Need only has to answer us. You can just search on this help any inventory model problems based on this. So inventory model, what you're going to solve. It's basically it is a tool to solve many of these things. If it's a matrix operation, definitely it can solve used. So I'm not sure about that. I did not use it for this. This can be used for linear algebra, graph theory, and calculus and algebra and other things. So even the abstract algebras, models and other things, Noetherian rings, we can use that. I'm not sure about inventory model using SageMath. I'm not sure about that.
Okay, sir. Because it will be a time-dependent function, but
Okay.
more number of variables. That is, I'm not telling about variables. More number of functions will be there because average cost, holding cost, like that. More number of cost functions will be there, but only one time, because all depends on time. It
Okay.
will be a like differential equation d by dt of whatever.
No,
Average
that's
cost
what I
total.
said. Differential equation, if you model it, then obviously you can use it. If you have a differential equation, then SageMath can be utilized to solve it.
Okay, sir.
Yeah.
Because there it won't be like a simple function. We'll have a like that is what I said, no, sir. Holding cost, total cost will be like add of all, but it will be like more than 4 or 5 lines. It will be a lengthy equation.
Yeah, you are talking about the ABC analysis, right?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Sensitive analysis.
Right. That is possible provided if you give the differential equation. See,
Okay, sir.
as such, you cannot say I'll give this directly. It has to frame the differential equation. It won't. No tool forms a differential equation. If you have a differential equation, then we can look into as a tool this one. That is the important part. That once you understood differential equation, you can use simulation using Simulink blocks also. So anyways, many tools are available. How to exploit for our purpose is the challenge. Hope I have answered you.
Yes, sir. Yes, sir.
Any other question from any of the participants? Please unmute yourself and talk.
Morning, sir.
Yeah, please, ma'am.
Shall we apply this for graph theory, or shall we apply this for graph theory or in PetriNet, sir, in any applications?
Yes, graph theory, graph models can be done, ma'am. Obviously, there is no doubt at all. There is a tutorial page available on the SageMath documentation itself. SageMath for graph theory. So that is possible. PetriNet is a directed graph, so obviously you can exploit it. Directly, there is no, see, if it is a MATLAB, we have a toolbox for everything. If you want to work on signal processing, I have a toolbox. Here, there is no such, but you can use the functions and everything possible.
For transition point, shall we apply this one, sir, for calculation?
Yes, when you construct the transition matrices, obviously it is possible.
For transition matrices, okay, sir. For transition purpose, for applying the automata theory.
No, because from the moment you talk about the stochastic process, it is slightly tough. So I have not explored it. So if you give a problem, then I can explore it, whether it is possible or not. That is the thing. The need has to make us to learn.
For generation, generating some picture languages or produce something. No. Okay.
No. That is obviously no. Obviously no.
Okay, sir. Thank you, sir.
For that, what you can do is a minimal tool has come from one is from German, another one is from IIT Bombay. There is a tool slightly different. All kinds of grammar, converting from one grammar to another grammar. There is a thesis available in IIT Mumbai, 5 years older. If I'm not wrong, 2015 or 16, one thesis submitted. That tool, they said they'll be hosting on the website so that anybody can use it to teach. What is the advantage of that tool is, you give a problem, it generates everything. So if they extend it further, I'm not sure.
Okay.
So that line you can think it of, you can be able to generate a tool based on that.
Okay, sir. Thank you, sir. Thank you so much, sir.
Any other questions from anyone? Okay, as there is no question, the feedback link will be sent to your registered email. Please check it and give your feedback. And let us move to the vote of thanks session for this wonderful workshop. So it gives me an immense pleasure to deliver the vote of thanks for this event to all dignitaries. First of all, I would like to thank our Secretary, Shri Ashok Kumar Mundra ji, our beloved Principal, Dr. Santosh Babu, and the Head of PG and Research Department of Mathematics, Vaishnav College, Professor Venkat Ramanan, for organizing this workshop. I would like to thank Venkatesh sir for giving us a wonderful lecture on Sage Math, which is really helpful in understanding mathematics and visualizing certain concepts. And I am sure this Sage Math is used in many fields such as linear algebra, graph theory, and optimization, which is like a backbone for the data science and all. So I really thank you, sir, for giving us this informative session on Sage Math. And I would like to thank our department colleagues for giving us constant support in conducting every workshop successfully, and particularly for this one also. I also thank our technical team for their immense support to make this workshop happen online. Last but not the least, I would like to thank all the participants to make this as a grand success. And I would like to thank, once again, I thank one and all present here. So thank you all.
Thank you so much. Yeah.
Thank you, sir.
Yeah.
Thank you.